We have with us Dr. Swastika and Das. She is a professor at BLD Engineering and Technology College, Vijaypur, Department of Basic Sciences and Humanities. She is a professor of chemistry. On behalf of KSTA and all the participants who have joined from both Cisco WebEx and YouTube, a hearty welcome to you, madam.
Thank you, sir.
And we
Thank
have
you so much.
Professor Kushal Das sir, who has always been with us and supporting us in all our programs and activities on behalf of KSTA and all the attendees. I welcome you, sir. I also welcome all the attendees to this very important talk by Dr. Swastika madam. Now, before beginning the talk, let me give a brief overview of achievements of Professor Swastika Das madam. Madam has done her BSc from Sambalpur University, Odisha, 1988. Subsequently completed her master's in physical chemistry from the same university in 1990 and pursued her MPhil in the Sambalpur University, completed in 92. After that, Madam pursued her doctoral in Sambalpur University and completed in 1998. She is specialized in physical chemistry. Her area of special interest are electroanalytical chemistry, phytochemistry, nanochemistry, and heavy metal toxicity. Madam has written 5 book chapters and edited one free radical medicine and biology book. And also, Madam has published many papers in journals of repute, both national and international, and also presented papers in national and international conferences. With this very brief introduction, I request Madam to deliver a talk on green chemistry. Over to you, Madam. Indeed, it is our privilege to welcome you once again. Over to you.
Thank you so much, sir. It is my honor to work on behalf of KSTA. And at the outset, I want to thank Dr. Ayappan, sir, Chairman of KSTA, and you, sir, Dr. Ramesh, sir, and Umesh, sir. So it is really a pleasure, and I always like to teach the students. So it is a good opportunity to uh, say a few words to them. So what I am going to say is about, of course, when we start a subject, we should know its background and what is the definition of green chemistry and how it can be implemented, and then I will conclude. So, if we go back to history, actually, green chemistry movement started with the publication of a book in 1962. The book name is Silent Spring, and the author is Rachel Carson. She actually started a movement like studying various adverse effects of the chemicals which are present in the environment and affecting the local ecosystems. So that we can say that the book is actually a wake up call for the public and scientists and as well as the government. So then everybody came to know about the hazardous effects of various chemicals which are present in the atmosphere. Then slowly, when it was realized that what she has written is very important, then she got a President's Medal from Jimmy Carter, the then President of USA. And slowly in 1970, the US government understood that there is a need to think about the protection of the environment, and they have started one agency. It is a very famous agency now, called as Environmental Protection Agency, in short EPA, which is a federal regulatory agency devoted solely to protect human health from the hazardous effects of the chemicals which is in the environment. Then, in this way, this decade also passed, and in 1980, in that era, people understand, all the scientists, chemists, industrialists, and the government understood that it is not enough to control the pollution. Okay, so it is important to prevent the pollution to occur. So, first and foremost duty for everyone has become that prevent the pollution by any means. So, 1980, the work started towards the development of preventing the pollution, and in 1990s, slowly EPA started working on it, and there they have understood that pollution control is not much important, but pollution prevention is important. And there one chemist was working, his name was Paul Anastas, and one more colleague of him was John C. Warner. So both worked very sincerely, and they published a book named Green Chemistry Theory and Practice, and this book was published in 1998. So this is one breakthrough in the direction of prevention of pollution. So in this way, we have started realizing that what is green chemistry is. Green chemistry is different from environmental chemistry, where in environmental chemistry, what we do is we control the pollution. Pollutants are created, and then we try to how to control, how to get rid of these pollutants. But green chemistry tries to cut down the root cause of the pollution. Okay, so if we look at the role of the chemistry in our society, or how much we are dependent on chemistry or the chemicals, we will see that in every field, let it be pharmaceutical, agricultural, food, medical, transportation, clothing, or our safety, or when we play games, or we are in office, we are at homes, we need these chemicals in our day to day life. We cannot say that this product is free of chemicals, no chemicals present in this product. That is absolutely absurd. So when we are handling the chemicals and so much dependent on it, we must know that which chemical is hazardous and which chemical is not hazardous. So in this way, this green chemistry practices started with the definition of green chemistry is, students, you just concentrate on this. Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Generation of the hazardous substances should be totally stopped. Then, because green chemistry also advocates the sustainable chemistry or sustainability. Uh, Therefore, how it is green chemistry is related to sustainability, or what is the sustainability meaning? So, sustainability means we, the elder generation, should leave something for the younger generation or the future generation. So, meeting the needs of the present generation without compromising the needs of the future generation. Therefore, sustainability should be practiced by making the chemicals which is safe for our health, then using industrial processes which reduce or eliminate hazardous chemicals, and we must design more efficient processes that minimize the waste. So we must see that the air, water, and soil is not getting polluted, so that the future generation can live a life very a healthy way. So aim of the green chemistry is to reduce waste, adverse environmental impact, and the cost effective use of renewable rather than non renewable raw materials should be there, and we should produce or manufacture the safer products. Then reduction in the use of the energy and resources, natural resources. We should reduce the use of these resources. Now, this is the how these principles of green chemistry came into picture. It was written in a book, and Paul Anastas, who is known as the father of the green chemistry, he worked very hard, and then he founded one foundation known as green chemistry. So he has not won Nobel Prize, but he has won a very prestigious prize from United States government, that is the Volvo Environmental Prize in 2021. Paul Anastas and John C. Warner, they have written guideline for practicing of green chemistry in their book, that is the Green Chemistry Theory and Practice. So let us see one by one what are the 12 principles of green chemistry. So first principle says or goes like this: prevention of waste or byproducts. That is, we must follow the acronym. Very often we use, that is, prevention is better than cure. So it is better to prevent waste than to treat or clean up waste after it is formed. Okay. So you can see that as the population is growing and we are very habituated in using the things, we are always run behind the material things, and thereby we are generating the metric and metric tons of waste every day. All over the world this is happening. So if a chemical process, if we talk about the chemistry and the chemical processes, these processes, if it produce waste, it invokes the need for its treatment and disposal. If we produce a waste, we should think that how the waste should be disposed of, whether we have the plenty number of landfills or scientifically designed landfills available to dispose the waste. And second thing is that if the waste is toxic, if the waste cause hazards, then the release of the waste into the environment leads to severe pollution, which further invokes the need for treatment and causing the added expenditure. So handling the waste is also not come cheap. It is also a very costly affair. Then second principle, which is very important principle and which the students should learn, those who are studying chemistry, they will understand better, that it is about the atom economy. Okay, so if a chemical process is not generating waste, then the process is called as a economical process. So atom economy can be defined as the measure of the atoms of the reactant that end up directly into the desired product. Always we know that chemistry means the chemical reactions. There are reactants which are converted into the products. Now the question is that how much percentage of the reactant is converted into the desired product? Okay, not the byproducts, desired product. So let us see that how it can be calculated, because an atom is a terrible thing to waste. We should not waste anything. So this is the formula. The formula goes like this, that is, to calculate the atom economy, we should calculate first the mass of the atoms in desired products divided by mass of the atoms in the reactants into 100. Okay, so synthetic methods should be designed to maximize the incorporation of all the materials in the process into the final product. Let us go for an example. Let us see here what is the percentage of atom economy for these reactions. Suppose magnesium carbonate is reacting with sulfuric acid to give the desirable product, that is magnesium sulfate. So in this reaction we get magnesium sulfate as well as water molecules and carbon dioxide. So if we calculate the molecular weight of the reactants, that is magnesium carbonate and H2SO4, we may see that 84 plus 98 together it is 182, and the molecular weight of magnesium sulfate is 120. So if we calculate this, if we calculate the atom percentage of atom economy, then we will find that 120 by 182 into 100, atom economy is 65% or almost 66%. That means what? 34% of the reactant is waste. 34% reactant is waste. Now see, look at the second example where there is reduction of the anisile aldehyde into anisile alcohol. So here the molecular weight, total molecular weight of the reactant is 136 plus 2, that is 138, and the molecular weight of the product is also 138. So if we calculate the percent of atom economy for this reaction, it is 138 by 138, that is 100%. That means this reaction is much efficient than the earlier reaction. So in this way, whenever we synthesize a product, we always see that the atom economy is maximum. If not 100%, at least it should be 90 to 95%. Then only the reaction is efficient. Now there are some more examples, like in their PUC students are there here. So they are studying so many organic synthesis reactions. You can see here this Glycine rearrangement and Wittig reaction. Both are there with the molecular weights of the reactants and the products. You can compare this. The Glycine rearrangement reaction atom economy is 100%, whereas for Wittig reaction the atom economy is only 20%. So which is a better reaction? It is Glycine rearrangement. So always try to find out the reactions which are economically, atomically economic, or which does not generates waste. That should be the chemical process synthesis. Then third principle tells us about the less hazardous chemical synthesis. So whenever practicable, synthesis methodology should design to use and generate substances that possess or no toxicity to human health and the environment. So stop generating or using hazardous substances. Now what does this mean actually? When we are synthesizing any kind of material, we must see that they do not contain any hazardous chemicals, or they do not produce any hazardous chemicals. For example, the firefighting foams, when there is something which catches fire, a building maybe or a surface or anywhere we have seen that there is fire and the firefighters are spraying water over the fire to extinguish the fire. So it is not always that you can extinguish a fire by spraying water. It depends on the nature of the fire, from where it has caught up, like whether petrol or the gas cylinder, what is the cause of the fire. So if water is not able to extinguish the fire, we can use a kind of foam. Now this foam is made up of, earlier this foam was made up of fluorinated surfactants. Surfactants are the materials, soapy like materials, which can create the foams, but they were containing the fluorines. And it has been seen that after the fire gets extinguished, these substances persist in the soil and they also mixes with the air, thereby they are polluting the soil, going down and mixes with the groundwater, and the groundwater gets polluted with the fluoride, which is very dangerous. So when this is recognized, then the substances which are fluorine free but can extinguish the fire were discovered. So this kind of firefighting foam which contains the hydrocarbon, surfactant, water, solvent, complex carbohydrate, is also able to extinguish fire, as well as they do not cause any kind of pollution. So this is a substitution example of substitution of a hazardous reactant with the non-hazardous reactant. Then let us go to the fourth principle, that is designing the safer chemicals. Okay, chemical products should be as effective as possible for their designated purpose but with minimum toxicity. Okay, so reducing toxicity should be a constant priority in chemistry. How to reduce toxicity, how to reduce the hazardous effects of the chemicals. But these chemicals should serve as the purpose, not polluting the environment, not causing any health hazard to the human beings. So let us see one example. This is a very famous compound, DDT. So, DDT is insecticide originally developed to kill the mosquitoes and to control malaria. All of us we know it, this substance, and we are using it also. But later on, it has been seen that this substance is very, very dangerous. It can damage the central nervous system of our central nervous system. So when this was recognized, many countries banned using DDT, and United States of America is the first of it. That is, Environmental Protection Agency's first work was to ban DDT. So if we are not using DDT, which is we can as good as a poison, then what can be the alternative? So alternate compound we have found out, that is benzene hexachloride, which is a safer insecticide. Then it has also got some kind of toxicity. Therefore, slowly scientists started working to find out the insecticide which is totally non-hazardous. And nowadays, including our country, we are depending on the long-lasting insecticidal net, that is LIN, which is not at all toxic and can kill the insects. And also, we are searching some plant based products which can uh, kill the insecticides and kill the pest. So, can act as insecticide and as pesticide. One good example is the neem oil. So, neem based products and other biopesticides now are available in the market. So, this is fourth principle talks about how to move towards the safer chemicals. Then fifth principle of this green chemistry is very important because it talks about the safer solvents and the auxiliaries. Now solvents, without the solvents we cannot carry out any chemical reactions. When we are mixing two reactants, the reactants are first dissolved in the solvents, then two reactants or three reactants are mixed with each other. All the substances, as we know, all of you know that all the substances are not soluble in water. So if they are not soluble in water, the alternate solvents are the organic solvents like benzene, carbon tetrachloride, maybe toluene, xylene, tetraline or hexane. So we use all these organic solvents. And also when we get products from the reactants, we always don't get one single product. The products may be also 2 to 3 products we get, and there is a need to separate the products. We want the desirable product which should be separated from the other products. So the process of separation also involves the use of the organic solvents. So what is the problem with this kind of solvents are that the solvents are highly volatile. They produces volatile organic compounds, vaporize very easily. Then they mixes with the air. And whenever these solvents mix with the air, they pollute the air. We inhale that air and we get affected with various diseases. As well as in chemical industry, various workers are handling these solvents, they are manufacturing these solvents, so they are also at a high risk that they fall sick. So if we are not using the solvent, fifth principle says that don't use organic solvent or reduce the use of the solvent by substituting the solvents with water as a solvent instead of chemicals, and various new harmless solvents are also developed. Then ionic liquids are also in the market, they are also doing fine as far as the hazards are concerned. And fourth one is more interesting thing, that is the supercritical fluids. The supercritical fluids are actually the supercritical carbon dioxide. So we can have the reactions occurring in the carbon dioxide medium, liquid carbon dioxide medium. Also, we can have, if we are not using any solvent, we can have the reactant conversion of the reactant to products in the solid state itself. So, two solid reactants we can take and grind it, and we can have the solid product. So, there will be no need of the solvents. So, we can substitute, or we should substitute and reduce the use of the organic solvents which are mostly carcinogenic. Then sixth principle tells us about the design for energy efficiency, that is any kind of chemical reactions require energy. So energy conversion, conservation of energy is very important, all of us we know. So in a process of chemical synthesis, a chemical reaction needs heating or cooling or stirring, distillation, compression, pumping, separation, all these processes. Whatever it is, suppose all of you know that a reaction takes place at a very high temperature, maintaining high pressure, or at a high temperature, maintaining low pressure. So, maintaining this kind of reaction conditions need energy. Energy comes from the electricity. Either we are using a heater or we are using Bunsen burner, flame or gas. So energy requirement is needed. So if we are using electricity for all these processes, electricity we get from mostly from the thermal power station. Thermal power station burns the fossil fuels. Fossil fuel burning creates the carbon dioxide which goes to the atmosphere, ultimately causing global warming. So what is happening here is the energy requirement due to the chemical reactions are huge, and from where to get this energy? Energy requires a resource, and mostly the fossil fuel which are non-renewable sources of energy. And second, another thing is that any chemical reaction, it is not like that it is going or finishing in one step. It requires lots of steps and it requires lots of time. Sometimes a chemical reaction, to finish a chemical reaction, it may require 72 hours, that is 3 days. So for the 3 days you will have to supply the energy. Okay, so here in this picture you can see that two examples. If we are not using the energy, or we want to reduce the source of energy, then what is the alternate? One of the alternate is we can have microwave radiation, where you can see we have a flame and we are have a utensil where the reactants are there, and when we are heating it with the help of a flame, the radiations from the flame, heat radiation, also heating the surrounding, then the heat goes to the utensil, from the utensil the heat goes to the reactant, then ultimately we get the product. That means what? Lots of energy is wasted here in the form of radiations. Okay. So if we can confine this reaction in a very closed space in a microwave oven, you can see here directly the radiation falls on the reactant, and the reactant is getting converted into product. No radiations are wasted, and very quickly the reaction gets finished. For example, you can see here the examples, various examples. A reaction requires conventionally it requires 15 minutes, but with microwave radiation it gets finished within 25 seconds. So huge amount of time is wasted, and time is saved, and the energy is saved. Similarly, 80-minute reaction is finished within 1 minute. 72 hours reaction is finished within 5 minutes. So this is the alternate method. If we are not using the conventional method, we can use microwave radiation, we can use the photochemical reactions. Nowadays we are using sunlight. If keep the reaction vessel under the sun, and the reaction will take up with the photochemical radiation, it will go and you will get the desired product. And also that ultrasonic wave also we can use as the alternate method. So various methods are there for saving the energy. Then seventh principle says that use of renewable feedstock. So whenever possible, we should use a reactant or a raw material or a feedstock which is naturally available and which is also renewable. Okay, so many common feedstocks are depleting. Non-renewable sources of energy and feedstocks are depleting, like petroleum and natural gas, and we use various kind of petroleum products like plastics, paints, pharmaceuticals, and many other products. So if we can replace these petroleum products by some biomass, this is one alternate, that is go to the nature and find out the feedstock to get your product. Then we can have carbon dioxide as a renewable feedstock, and we can have methane as the renewable feedstock. So carbon dioxide and methane, these are actually used in the fuel cells. Nowadays these fuel cells are also the alternate source of electricity, and these fuel cells are used to run the electric vehicles. These can use the carbon dioxide and methane, and from the methane also we can generate electricity. This happens in the scientific landfills. In the landfills, from the waste lot of methane is produced, and these methanes are used. Nowadays technology started, methane is used to generate electricity. So this principle, this seventh principle also implies the use of the renewable energy resources like solar, wind, biomass, biofuels, hydropower, etc. And good example of using a renewable feedstock is that the production of the biodiesel. Diesel, all of you know that diesel we get from the crude oil by fractional distillation. Petrol, diesel, kerosene, different fractions come up, but not using that petroleum or crude oil, we can use any kind of oil like coconut, mustard, or this one, sunflower, any oil. What comes in your mind? Any oil can be converted into diesel, and that is known as the biodiesel. So it is a very good example of using the renewable feedstock and producing the energy. Then reduce derivatives. The eighth principle says that reduce derivatives. So reducing derivatives means what? A chemical reaction goes up and gives the product after many steps. Like a reactant A, we go to B, B to C, C to D, D to E, E to F, like that. The chain of reaction goes on. and ultimately we get the product after several steps. So as many steps are involved in a chemical reaction, that many number of byproducts are generated. A to B to C to D. B is not required, C is not required, D is not required, E is required. So instead of going through several steps, we are generating the byproducts and we are wasting the materials. All materials are not needed. Then by this process we are using lots of reagents. Okay, that is again the waste. It pollutes the environment. So instead of so many steps, if we wish to cut down this waste generation, we can go for single step reaction directly from reactant to product. So a single step reaction can be more atomically economical. It reduces the use of lots of chemicals and lots of energy, as well as it saves time. So you should go for the chemical reactions, chemical processes which does not use the derivative or depend on the intermediates, and which are usually the derivative of the original reactants. Then ninth principle, which is very important, it is catalysis. All of you know that catalyst is a substance which enhances the rate of the reaction and it does not get consumed during the reaction. Whereas the stoichiometric reagents are the reactants in the chemical reaction which are consumed during the reaction. Okay, so this is the comparison between a catalytic reaction. The catalyst comes out as it is and binds the reactant and the product, we get the desired product, then we can reuse the catalyst. Okay, but in a stoichiometric reaction you can see lots of reagents are used and there is lots of waste generated. So catalytic reactions are better than the stoichiometric reactions. Nowadays we are using biocatalyst also. Biocatalyst are actually the enzymes, and catalyst also reduces the potential energy needed for a reaction to happen. This is the energy barrier. Energy barrier, reactant crosses this barrier and goes to the product side. Product, we get the product. So if you are using enzyme as a catalyst, then the energy required for a reaction gets decreases. So all the principles so far we have discussed it, its summary is like that. We can see this the synthesis of the adipic acid in two methods. First one is the conventional method. You can see the precursor starting material is the benzene, which needs this nickel, Raney nickel and aluminum oxide as the catalyst, and high at a high pressure the reaction takes place, and in this process lots of nitrous oxide is also generated which pollutes the atmosphere. Okay, and benzene itself is carcinogenic, it causes cancer. So adipic acid is such a substance which is needed, like you can say, throughout the world, 3.3 million tons of adipic acid is needed for the manufacture of nylon, then various plastics, PVCs. So it has huge application. Adipic acid has huge application. Therefore, what happens? We should find out a way which is non-hazardous way, non-toxic way, and the that synthesis or the green route for the synthesis of adipic acid is discovered. That is, we can have adipic acid from the fermentation of glucose, and this fermentation of glucose uses Listeria coli, that is a bacteria. So in the presence of this bacteria, it is a bioenzyme, we can say biocatalyst. Glucose and this biocatalyst ultimately gives the adipic acid. You see here, no high pressure is needed. Ultimately, this is cis meconic acid. This is one of the pathway to get the adipic acid. So this platinum hydrogen. These are the reducing agent which reduces the mucinic acid to adipic acid. And not only the Escherichia coli, various bacteria and microorganism scientists are using to see that how to get glucose, more amount of glucose from the adipic acid. And this is the hot topic of research nowadays. And several this kind of reactions are there. Like for example, catechol synthesis can be done in green ways, paracetamol synthesis can be done in green ways, ibuprofen can be done in green ways. So you can search for it, that how to go green for a chemical synthesis. Then design 10th principle says us about the design for degradation, that is a chemical product should be so designed that at the end of their function they do not persist in the environment and break down into innocuous degradation product. So most of the time we have seen that various materials are there. For example, good example is plastic, then polystyrene. So many products are there which do not degrade itself. So these are more dangerous for the environment. But nowadays, this green principle says that we must design the chemical products in such a way that after their use, when we are throwing them into the environment, in the landfill, they should be degraded into small harmless products. Innocuous degradation products means small harmless products. So a big molecule should be decomposed into the smaller molecules, and the smaller molecules should be easily either it will mix with the soil or it will evaporate in the atmosphere without causing any harm to anyone. So DDT is a non-biodegradable one example and cause severe problem. So a product must be designed such that it degrades to innocuous products in the environment. That's why we are depending now on biopesticides. Then one of the product, that is, instead of plastic we can use bioplastic. Bioplastic is made up of polylactic acids, and polylactic acid, this bioplastic can be very easily made up from cornstarch, or you can use agar agar mixing with the vinegar and little amount of oil, add some microwave radiation, and you can get the bioplastics. These are the small projects which the students can do to find out the substitute for the plastic, what they can do. So this is one of the very interesting project the PUC students can do, take up. Then 11th principle, that is real time analysis for pollution prevention. So we must have some analytical methodologies, or we must have the technology, we must have the modern machines which allow for real time in process monitoring and control prior to the formation of hazardous substances. As soon as the hazardous substance is formed, the machine should give a signal that this product is not okay. Or as soon as the desired product is formed, the machine should send the signal that yes, the product is ready. If the product is not forming during a chemical reaction, the machine should say that the product is not going to happen. So we can stop as soon as we get the signal from the machine. So in this way we can save energy, time, and the hazardous products in making. So we need to develop in the technology also, get the good machines, modern machines, which will help us to synthesize a chemical product. For example, we can have the NMR analysis machines, nuclear magnetic resonance spectra we can take, and we can take some sample from if we are synthesizing a chemical, we can take out small amount of sample and subject it for NMR analysis, and this analysis will tell us whether we are going to get the correct desired product we wish to synthesize. So various kind of spectrophotometer, NMR analysis, mass spectrophotometer, lots of instruments are available. Then the last principle of the green chemistry is inherently safer chemistry for accident prevention. This is also important. That is, as a chemist, as a scientist who are synthesizing the products, handling the chemicals as reactants, they must see that this reactant should not cause any kind of explosion, should not cause fire, should not produce any kind of harmful substances in the form of gases or in the form of liquids. So, to avoid the accident, we must take care. We should not handle the reactants, we should not go for a product which causes the hazards. For example, one thing is that when the care was not taken in the year 1984, Bhopal gas tragedy occurred, and this gas involved was methyl isocyanate, which killed so many people, and still people are suffering for it. And this is due to the carelessness. So, such kind of hazard should be avoided. Always we should see for it, and you should be serious for it. Now coming to all the 12 principles I have told, and it looks like that maybe students might have felt that it is all theoretical. What is the practice? What is the use of it? Why should you know it? But if you concentrate on these principles, one principle is enough to do the research in one direction, and the proof is that any one principle you take and you work on it, you can start an industry, you can start a startup, or you can at least get a can be recognized as a very good scientist. For example, these examples are there that practicing the green principle or working in this line with green principles, taking into consideration three Nobel Prizes. Three Nobel Prizes the scientists have got in 3 different years. You can see here 2001 the scientists got the Nobel Prize. They worked on the synthesis of chiral catalyst. Okay, all the works on catalysis only. So they prepared chiral catalyst which can produce the mirror images, two products, mirror image product, but we can select only or produce only one mirror image. Like the medicine L-DOPA. L-DOPA is this scientist, their work helped to discover this L-DOPA medicine, which is a very good medicine for Parkinson disease. Then in 2005, three scientists they have got the Nobel Prize for metathesis. Metathesis is also one kind of finding out the newer chemical product, new chemical product which are safe. They have found out that mechanism, and this is helping the pharmaceutical industry to find out the drugs which are not very toxic, because when we are using various drugs, some drugs are neurotoxic, some drugs are nephrotoxic. So how to reduce the toxicity of the drugs, all is about the chemistry or chemical reactions. And very recently another two scientists, List and Macmillan, got the Nobel Prize in 2021. They worked on organocatalysis. That is, this has had a great impact on pharmaceutical research and has made chemistry greener. So all three prizes were won following the green chemistry principle, and here lies the importance of green chemistry. Why this I have chosen this topic as my lecture. So examples are, various examples are there. Very funny thing, that is CO2 we are using. CO2 can be captured from the atmosphere. Very funny, isn't it? So we never thought we can capture CO2 from the atmosphere. So these companies are working on capturing the CO2. So I want to conclude here, from perfumes to plastics or farming to fabric or dyes to drugs, we require the inexpensive renewable sources and environmentally friendly sources for the chemical reactions to occur. And green chemistry is the future of all of us. And what the students learn from it, they learn problem solving, critical thinking, argumentation, collaboration. I hope one skill will be developed uh, from the student will get. And these are the questions for the students. They can send the answer to Dr. Ramesh sir. And I want to conclude here my this lecture, what is the importance of green chemistry and how we can proceed for a greener future. Thank you so very much for patient hearing.
Madam, thank you very much for an excellent presentation. Indeed,
Thank you, sir.
it was, I'm sure students will get a lot of take-home message from your talk. You spoke so well about green chemistry, a greener future, and right from history of green chemistry, from Silent Spring, you went on to speak about Environmental Protection Agency, which was started in the US by Richard Nixon, then sustainability, atomic atom economy, then 12 principles, really excellent principles highlighted. All those were, some of them are really very new to students, and insecticidal effect of DDT. In fact, to add to what you
Yes, sir.
have already told, the DDT was discovered by, as we know, it was by Ottmar Ziegler in 1874.
Yes,
And it
yes.
became very useful during Second World War to prevent insect-borne diseases like malaria. But
Malaria.
in fact, Ziegler was not the person who invented the insecticidal effect of DDT. He only discovered later, in 1939. Paul Hermann Mueller was the person who invented the insecticidal effect. It was not the inventor who got the Nobel Prize, but it was a Mueller who got the Nobel Prize in 1945 for discovering the insecticidal effect in physiology, in the field of physiology. He got the Nobel Prize. In fact, it was a very interesting subject you have chosen, madam. Green chemistry is the future. In fact, we have to follow 12 principles, what you have told. Reuse, reduce, and recycle is the 3 R's which we should follow if we have to uh, develop sustainably. Thank you very much for your excellent presentation on behalf of KSTA and all the attendees, both on Cisco WebEx and YouTube platform. Thank you very much, madam. And in fact, KSTA is very thankful to you. Being a KSTA associate, you are not taking honor of him. We are grateful to
No,
you.
sir. It is it is a pleasure and honor, sir. And thank you so very much. You have given me the opportunity.